And we're starting here with 8.6. We got the binomial theorem. We're going to be bringing together Pascal's triangle with combinations. All right, so let's look at this first one. Getting started. We've got this list of numbers, and we need to know which row from Pascal's triangle are we talking about. And how do we know that? Well, first of all, we're going to look at the second number. Always looking at that second number or the second last number. They're both the same because Pascal's triangle is symmetrical. And the row number and that number are related. The second number is always one less than the row number. So then that's going to be the 12th row. Or you could look at it as adding the first two numbers up to get 12. Another way of looking at it is that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 terms, so it's the 12th row. And using our combination notation, we want to look at the fifth term. So the fifth term is 1, 2, 3, 4, 5, right there. Well, that's going to be NCR. Our n value is going to always be one less than the row number. So I'll say row number minus 1. And our R value is always going to be term number minus 1. So we've got row number is 12. 12 minus 1, that's 11. C, term number is 5. 5 minus 1 is 4. 11C4. And just to remind you about what Pascal's triangle is talking about. Pascal's triangle is saying that if we add the two numbers directly above and at angles, we will always get that number. And the color coordinating here is actually quite neat as well. You notice all of the ones that are colored in blue are even numbers. And if we start going through and taking all the even numbers and coloring them in, you're starting to get triangles within triangles, and that leads us to a geometric pattern called Sierpinski's triangle, which we're not going to be discussing in this section here, but it's something that's related to Pascal's triangle, and it's quite amazing in itself. The whole point of this lesson here is to be able to expand binomials. So we got to remember how to do that. If we're looking at something like this one here, 2x minus 3 squared, you can't just distribute in the exponent. You got to expand it by saying 2x minus 3 times 2x minus 3. And most people remember what the rule for that is. Square the first one, square the last one, multiply the two of them together, and double it to get the middle term. So if we have something that's cubed, break it into a squared and to the 1. Then you can expand the squared using your pattern, and then we bring in and distribute in that last binomial into there, as you can see all the way through. Same thing here, taking the fourth into two squareds, expanding them, and then expanding those two trinomials. And we need that for expanding x plus y to the 0, 1, 2, 3, and 4. And then, hey, there's a pattern. Let's figure out that last one to the fifth without actually having to expand it. So let's look at this first one. X plus y to the 0. Hey, anything to the 0 is 1. X plus y to the 1. Anything to the exponent 1 is the same as it was. 1x plus 1y. I'm going to put in the coefficients even if they're 1 here. There's a reason for that. Then x plus y squared. We got that nice rule, 1x squared, and way over on the other end, 1y squared, and then the middle term is multiply them and multiply by 2, 2xy. Now when we get to the next one, we'll change colors here, x plus y cubed. That's the same as saying x plus y times x plus y squared. Hey, we just did the squared right above it, so let's just bring that one in. x plus y times 1x squared plus 2xy plus 1y squared. And now we expand that binomial into there, which now gives us x cubed plus 2x squared y plus xy squared plus x squared y plus 2xy squared plus y cubed. Let's combine all those like terms and simplify it down to 1x cubed plus 3x squared y plus 3xy squared plus y cubed. You don't have to have the coefficients of 1 in there. You could leave them blank. I'm doing that for a reason. And now we do x plus y to the fourth. If we're going to the fourth, that's the same as saying x plus y to the 1 times x plus y cubed. Hey, we just did the cubed right above. X plus y times x cubed plus 3x squared y plus 3xy squared plus y cubed. And then we expand that and simplify it. I'm going to jump straight to the simplified version of it, which would be x to the 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4. I'm going to throw in my 1s there. Notice the coefficients. 1, 4, 6, 4, 1. Hey, I've just seen those when we talked about Pascal's triangle in 8.5. Look at this. 1, 3, 3, 1. Hey, that's Pascal's triangle. 1, 2, 1. 1, 1. Look at those coefficients. We're making a pattern. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Nice. We can also notice that our degrees, our exponents on the variables go from 4 to 3, 2, 1, and x to the 0. Y to the 0, y to the 1, 2, 3, 4. So the x's go down, the y's go up. We can use that when we do x plus y to the 5th. So if this is x plus y to the 5th, we're going to throw down our coefficients from Pascal's triangle, 6th row. 1, 5, 10, 10, 5, 1. And now we're going to do our x to the 5 goes down by 1, x to the 4, x to the 3, x to the 2, x to the 1, x to the 0. Don't have to put it. And then we're going to do our y's. Y to the 0, y to the 1, y to the 2, y to the 3, y to the 4, y to the 5. And now let's put in our plus signs. Plus, 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 plus. Expanded. Didn't have to take the time to expand the full thing. Okay, so bringing that all together here, we're going to compare them. So when we expand to the 0, that's row 1. When we expand to the 1, that's row 2. When we expand to the 2, that's row 3. And so forth. Cubed is row 4. To the 4th is row 5. Look at the coefficients on each one of them. It's from Pascal's triangle. And then, as I said, we're using the coefficients from Pascal's triangle. And then from the x, we're decreasing from the power of n, whatever the exponent was, all the way down to x of 0. And then for the y, we're going from y to 0 up to y to the n. A nice question they'd like to ask is, how many rows are there in the expansion of something to the 6th? There's always one more term than that n, so it'll be 7 terms, or 7th row. Notice this as well, that the n value is always that second number. It's also the second last number. And then you can see, if we're expanding to the 6th, we're using the 7th row Pascal's triangle and going down from x to the 6, down to x to the 0, y to the 0 up to y to the 6. Also, if you add the exponents in any one of the terms, it'll always equal the end value. 6 plus 0, 5 plus 1, 4 plus 2, 3 plus 3, and so on all the way through. All right, we're going to expand this baby. 3b minus 1 to the 4th. Well, the first thing we want to look at is what would have happened if we would have had x plus y to the 4th. And then we'll go from there. X plus y to the 4th would have been, hey, that's the 5th row of Pascal's triangle. And the numbers that go with 5th row are 1, 4, 1. Those are going to be my coefficients. So I've got 1, 4, 6, 4, 1. And then I'm just going to put in my plus sign. Oops, shouldn't put it there. Plus. And now with our x values, we would have had x to the 4, y to the 0, x to the 3, x to the 2, x to the 1, x to the 0. And then with the y's, y to the 0, y to the 1, y to the 2, y to the 3, y to the 4. But I don't have x and y in this at all. I've got 3b and negative 1. So what you want to do is write on the side that in the x spot is 3b. In the y spot is negative 1. So that I don't have to do this first line. I could jump straight to the whole thing. Well, this would be 1. In the x spot is 3b to the 4, negative 1 to the 0, plus 4 times x, that's 3b to the 3. In the y spot is negative 1 to the 1, plus 6. X is 3b squared. Y is negative 1 squared, plus 4 times 3b to the 1, negative 1 cubed, plus 1 times 3b to the, running out of room, sorry, 4. And when we simplify within this, I've got 3b to the 4. That's 81b to the 4, plus 3b cubed multiplied by 4 multiplied by negative 1 to the 1 is going to give me, not plus, that's going to be a minus now. Minus. If I multiply that all together, expand that, I get negative 108b cubed. Negative 1 squared is going to be a positive 1, so this is going to be plus 3b squared times the 6 gives me 54b squared. And then negative 1 to the 3, that's going to be a negative. So negative 4 times 3b minus 12b. 3b to the 4th is not correct. That was a silly error. Sorry about that. That should be 3b to the 0 and negative 1 to the 4th. That makes more sense. There we go. And negative 1 to the 4th, that's positive 1, so this is plus 1. All good. That's simplified. Done deal. But here's where we start bringing together the rows of Pascal's triangle and combination notation. Because we don't want to have to go through and find all 10 rows in order to find the 11th row. We want to be able to jump straight to there. So row 1 was equal to 1. And from combination notation, we already learned that that was 0. Choose 0. Row 2 was 1 and a 1. And that was 1C0, 1C1. Carrying that on, we now get all of the rows from combination notation. Look carefully at this. Row 1 was when something was to the exponent of 0, to the exponent of 1, to the exponent of 2, to the exponent of 3, to the exponent of 4. Let's look at where all those numbers can be found. Second number in the row, hey, there's nothing there. That's a 0. Oh, look at that. That's a 0. 1, second number is a 1. Oh, look at that. There's those 1s. A 2, second number is a 2. 2, 2, and 2. Oh, man, look at this. 3, 3, 3, 3, 3, 3. 4, 4, 4, 4, 4, 4, 4. Cool. So this is saying here, if our exponent is n, we're on the n plus 1th row of Pascal's triangle. And then we would use our combination notation of starting with the n all the way through. All right, we got 2 questions back to back here on the bit.ly link. We got Pascal's triangle. Hey, which row are we talking about there? And second question is, where would that specific coefficient be in Pascal's triangle? Which row and which term number? Okay, so in the expansion there, we've got combination notation. This is the one you're really going to use a lot more of instead of the algebraic expression, because you've got that NCR button on your calculator. It's just easier to use. But you can take it to algebraic and do it with the expanded factorial form. But I would definitely focus on that first one. And this is on your formula sheet. It's on the bottom of the left column. It says in the expansion of x plus y to the n, you have the term is t, k plus 1 equals n, c, k, x to the n minus k, y to the k. And we'll get to that as we work through this. All right, number 2 then. Let's expand and simplify this. We're not going to go right back to using the line on Pascal's triangle. We're going to get using our combinations. So we're looking at this and we're saying, hey, we've got this number right up here. That's our n value. N is 3. So write it on the side, get all of your information down. If n is 3, x is 4a squared, and in the y spot is 2b. We got those 3 written there. Now we can just start plugging into our formula that we have on our formula sheet. The first one, n is 3, so we're going to have 3c0 as our first coefficient, multiplied by x to the 3. Well, in the x spot is 4a squared to the 3. And then in the y spot is 2b to the 0. You don't have to put that to the 0. You could leave that blank because that's just going to equal 1. Plus, now we go to the next one is 3c1. That's the coefficient. And then the x, or a squared, and the exponent comes down 1. And now the y goes up 1. Plus 3c2, the x value to the 1, and the y value to the 2, plus 3c3 now, and the x value to the 0. You don't have to include that to the 0. You could have just left the blank. And the y value to the 3. And now just collect your like terms, expand that. Punch into your calculator. 3c0. That equals 1. Then 4 cubed is 64. A to the 2 to the 3. Multiply the exponents, a to the 6. And 2b to the 0, that's just 1. Plus 3c1. That's 3. Then we've got 4 squared, 16. A squared squared, a to the 4, and 2b. Plus 3c2. That's 3 as well. 4a squared, and 2 squared, 4b squared. Plus 3c3, that's 1. 4a squared to the 0, that's just 1. 2 cubed is 8. B cubed. And clean that up a bit more. 64, a to the 6 plus Multiply that in. 3 times 16 times 2. 96a to the 4b plus 3 times 4 times 4. 48a squared b squared plus 8b cubed. We've expanded that without having to write it and actually go through the full process of expanding. Now this next section that's in your book I am going to adjust because they do it differently in here than it is on your formula sheet. I'm going to change it up right now for you. On your formula sheet they don't look for the kth term. They look for the k plus 1th term. The way that it's written, like I said, it's in the second column, very bottom. It says, in the expansion of x plus y to the n, same thing here, t k plus 1 is equal to nck times x to the n minus k times y to the k. So I'm going to stick with this notation, where k is 1 less than the term number you're looking for. So if you're looking for t5, let's say, k plus 1 is 5. So that would mean k is equal to 4 in that situation. Your k is 1 less than your term number. And that's been holding true all the way along. We've always been going 1 less than. Row number minus 1, term number minus 1. This is term number minus 1. So the question then is, determine the 9th term of this expansion. 4 things we need to figure out. What is the n? What is the k? That's the hard one. What is the x spot? And what's in the y spot? N is easy. N is the exponent. That's 10. K value. We'll come back to that one. That's the tougher one. In the x value, that's whatever's sitting there. And in this case, it's x. The y value, that's the minus 2 sitting in there. Now the k. The k is dealing with the 9th term. So T9 is what we're looking for. Well, t is k plus 1 from your formula sheet. So we're going to say 9 is k plus 1. So subtract the 1. K is equal to 8. Or always remember, k is 1 less than the term number. And now we just go straight to our formula sheet and we plug it into the formula, which was tk plus 1 equals nck x to the n minus k, y to the k. Right, let's plug it in. K is 8, so this is t8 plus 1, which is going to give us t9. Good, that's what we're looking for. Always do that first just to make sure k is correct. N, 10, c, 8 multiplied in the x spot is x this time. N, 10 minus the k minus 8. In the y spot is negative 2. And k is 8. And that gives us T9 is equal to 10C8. Plug that straight into your calculator. Gives you 45 x squared multiplied by negative 2 to the 8. Plugging that in, 256. Make sure when you plug it in, you're plugging with brackets around the negative 2 to the 8th makes it positive. Multiply the 45 and the 256. So T9 is equal to 11520 x squared. That is the 9th term. There's lots of relationships that need to be made from this topic. So go through those, answer those 2 questions, make the connection for yourself.